This is making robust decisions. This is sort of an introduction to what we do and our attitude towards decision making. What we mean by a robust decision is there's the admission that in robust decision making that everything's uncertain. And the best you can do is make the best possible decision, and you don't even know if you've made the best decision ever. You can do some hindsight and say, well, it was a good decision, but you have no way of knowing it was the best one unless you can do two paths simultaneously, and no one's really figured out how to do that. So, you're resource limited, you got uncertainty, you'll never get rid of all the uncertainty. The goal is to know the direction forward and understand the risks of doing that and pick one and go forward. And by this definition, doing nothing, sitting there, is one of your options, and if you do nothing, you have chosen to do nothing. So the way we look at decision making is there's different kinds of information that we work with. The lowest form is just raw data. If you know the relationships of data, you can build models. And if you know the behavior of the models, you have knowledge, and if you can put human judgment on that, you can make a decision. And increasing value as you go up this pyramid. What's interesting about this little project, and the thing I was beating on so hard at the meeting that we had in Bethesda, was that a lot of people were talking about we've got all these great models people have built, and we're going to run models. And I'm sitting there waving my hand saying, no, anybody can run a model. And I think there's a great quote, I believe it's by Niels Bohr, that basically says, all models are wrong, some models are useful. And so the goal is to use these models to help people make decisions. Now the neat thing about this pyramid is that if you look at the history of computers, they start out with just massaging really simple data through very simple relationships, and then the relationships and models got more and more sophisticated, and now computers try to help you understand behavior. So the computers are sort of bottom up, and the decision making and judgment is pretty much top down. And people have wrestled for years in the AI community to help computers chip away at the top part of the pyramid, and there's a lot of good AI stuff that's helped that. However, in industry, decisions are notoriously pretty poor. There's a really great book, Why Decisions Fail, by Paul Nutt. And what he did, he went into corporate offices and interviewed people. And basically what he tried to find out was, did you make a decision about some topic? And if so, what happened after the decision? And what he found out was that 2 years later, there was no evidence of 50% of the decisions made. In other words, by his definition, that was a failure. There was no evidence that it had ever been made. In other words, people walked out of the room, they did something else. It had no sticking power. And he said there were 3 classes of blunders here, and one of them is the practice of making decisions is failure prone, and I'll talk about that some more as we grow along. Also, people make premature commitments. They say, we're going to go this direction before they really have all the information. And people like to spend time and money on the wrong things. They like to spend time and money on the things they understand and know what to do about. Engineers are really, really good at this, by the way, of let's go do some more analysis, let's crank some more numbers. And, those may not be the right numbers to be cranking, and so it's hard to know. The table on the right is some information that's unpublished from NASA. And basically, NASA has different levels of projects. And when they first start a project, they try to guess how their uncertainty in terms of how much over budget is their project going to be. And standardly, the company that's going to do the satellite or whatever the experiment is makes an estimate. NASA puts 15% reserve on that estimate, sticks the 15% of dollars in their pocket, and doles it out as needed to get the project finished. The problem is that over and above the reserve, these percentages are what the reality is over the last few years. And so you can see on the small technology experiments, they've been over by a factor of pi on these less than $10 million experiments. So So, that's not all due to decision making, but a plan a plan is a series of decisions that you have to make. So anyway, so when you're working through a decision, there's a whole bunch of key questions. Here's 5 of the ones that I think are important, and these are the ones you have to keep asking yourself. People are used to thinking about decision making that's just which is the best alternative, but what to do next, and what do we have to do to get buy-in from all the other constituents are equally important. So this is a diagram I use to sort of explain how I look at decision making. If you start in the upper left corner, the hard part's framing the problem. I've got a contract right now with the Veterans Administration, and we're 3 weeks into trying to define the problem, and we have to have a report on that in another 3 weeks. And we just had a telephone conversation this morning where one of the stakeholders said, no, you're going the wrong direction. So that's going to be more fun. So, and by defining the problem, I mean, what's the issue you're trying to solve? I can't even get the VA people to agree on that. Then what are the alternatives you're going to compare and contrast? And if you only have one alternative, it's a justification, it's not a decision, so you need multiple alternatives. How are you going to judge those alternatives? What are the measures? What are the things people are going to talk about when they talk and compare and contrast the alternatives? Then you actually have to do the evaluation. So if one criteria is how fast is the new car going to be, you actually have to go get some numbers on how fast it is. Either from the manufacturer's specifications, measure them yourself, ask a buddy. Somehow you're going to evaluate this. And then somehow, by magic, you've got to fuse these together, because if there's multiple decision makers, multiple evaluators, they may see the information differently. They may have different sources of information. They may have different value structures. I've got another project I'm working on that's got to do with the placement of wave energy devices in the Pacific Ocean off the coast of Oregon. And there we have, it's a pretty interesting project. It just hit a glitch. The program manager decided to go to grad school and get his PhD, so we're in the midst of, after I get off the phone with you in a half hour, I get to talk to the new program manager. Anyway, there we have constituents, stakeholders that vary from fishermen to fish huggers to people who want tourism along the coast to shipping industry to the energy companies, and they don't agree on anything. And somehow, if we're going to make a good decision, we've got to be inclusive of all these people, and that's what the fuse box is all about. Then you have to decide what to do next, and I really love this quote from Arthur C. Clarke at the bottom. And it's more than choosing an alternative. It's, as I mentioned before, it's all these other things thrown in there too. So, and the kicker on all of this is that everything in here is uncertain. You don't have good information on anything. And I'm working with scientists on this wave energy problem. They're oceanographers, and they give lip service to uncertainty. But boy, when you start to push them, how deep is the ocean here? They say, well, it could be this deep, it could be that deep. And I said, okay, we've got to take that into account, that you don't even know how deep the ocean is. So, recently the government has started to take notice that the decision-making process is fraught with problems, and this comes out of the Department of Defense. It's called Analysis of Alternatives, and OMB is doing it too. And what they're basically doing is what I'm doing, and they just gave it a new name, and it's pretty cool because I'm trying to ride on the coattails and get some more government contracts. But I wrote a paper that's just recently published. It says, well, there's 4 levels of AOA maturity. And level 0 is you propose one alternative and justify it, like I said before. Level 1 is what the OMB does, and the OMB is all about dollars. So they reduce everything to net present value. And level 2 is what DoD does, and they say, well, you've not only got costs, but you got other measures of effectiveness, criteria, if you will, that you have to take into account. The thing they don't do real well is take the uncertainty into account. And so that's level 3, defined by me to be very self-serving because of the uncertainty. So I don't know if you've ever seen a little table like this. This is really common in business and engineering. It's called a decision matrix. And what you do is you list your alternatives in the columns, and you list your criteria in the rows, and you weight the criteria about what's most important, and you give a score. Like, there's all kinds of ways of doing this. This is like a 1 to 4 score. 4 means that vendor 1 meets the cost criteria, and pretty well. And a 1 means their ease of use is not so good. And so here's some scores, and you can add up the scores, or you can multiply the scores by the weighting factor and do a weighted sum. And this is a really, really common method, and this was a method I was using in teaching back in the 90s when I started looking for better methods. But it's got some real problems here. And first of all, the numbers 1, 2, 3, 4 don't really have any meaning. And then it doesn't make any sense because cost is something that you can measure directly, in dollars. And team experience, well, you could probably come up with some kind of measure if you had to, but it's much easier to say it's an experienced team, it's a not so experienced team, do something much more qualitative than quantitative. So be nice if you could connect those things together, which is the third box down, so it's sort of the same thing. Then you got the problem of, well, let's say you and I are on the same team, and I think this is a 4, and you think it's a 3, or Jane thinks it's a 1. What do we do? How do we take that into account? And what do you do with the uncertainty? For example, let's say vendor 1 are the guys I've been working with forever. And when I give them a score, I know exactly. And vendor 3, I've done one project with, and vendor 4, they're brand new to us, and I have no idea. They gave me a cost proposal, but geez, are they always on time? Never on time? Oh, it looks like I used a 1 to 5 scale. There's a 5 there. By the way, the reason vendor 2 is missing here on purpose is usually you filter out alternatives before you even get this far. So these are the ones that you can't differentiate amongst. Think of what happens when you get a pile of resumes for a job position. If you're like everybody else, you divide them into 2 piles. Those I might be interested in, those I'm definitely not interested in. So these are the I might be interested in these pile. And now you're trying to differentiate among those. Let's see. Yeah, that was my... Okay, give me a second here to do a little bit of a transition. Okay, you should see a bluish-gray program with some colored bars on it. And do you see that? That's a good thing. This is a chord. A chord has a number of different versions about it. This is a standalone version. There's a server version. There's a SaaS version. There's an API. They all do basically the same kind of thing. And so the way a chord works is very similar to that decision matrix, except it lets you do a whole lot of other things. And underneath there's some fairly sophisticated mathematics that lets you do these things. So I'm going to do a really quick overview of a chord, and if you're interested, you can go to the website robustdecisions.com and download this exact same version and play with it and figure out which washing machine you should buy. So this is actually a sample I put together for a presentation at the Veterans Administration a couple weeks ago, and I just figure I might as well use real stuff. So the issue is, what's the best strategy for the Office of Research and Development research portfolio? So they're looking for a strategy to manage their portfolio of projects. And Down here I put in the different alternatives that they were talking about. You know, they might build their portfolio around the frequency of diseases that veterans see, um, by the healthcare costs. They may do gap filling. By that I mean do research on the areas that NIH and DoD are not doing research. Um, Try to anticipate the problems in the next war. So these are all different strategies that they might use to allocate their funding. Now in Accord, you can put in a new criteria just by clicking the new button, and I'll just type new, and it'll pop up another criteria, and you might have noticed that there's an orange dot next to this and an orange bar appeared over here. Everything having to do with the alternatives are color-coded. And so these colors go along with them. The other thing you can do here is if you right-click, you can link to documents that might be supporting this. You can add comments. So if I add a comment, something stupid, so then the little flag comes up and says you got a comment there, and the little pop-up comes up. So pretty straightforward stuff. I'm going to get rid of that. Oh, what did I do? Okay, I got rid of it. Here are the criteria, and just like the alternatives, you can type in new criteria. And so let's just look at a typical criteria. So this criteria says good alignment with VA goals. So that means we're going to evaluate each of these alternatives by their alignment with VA goals. By default, it's a qualitative assessment. So this means it's effectively a yes-no kind of question, but you'll see there's some gradations on that as I get further into this. But that's the starting point. So if we, let's go to this one up here. I'm going to double-click on that and open it. So this is, we're going to evaluate each of these alternatives by high research ROI. And here I've clicked on more is better, and I've said I'm going to be delighted, and I didn't put any units in there, so we're going to call this, well, ROI is a ratio, so we'll just call it a ratio. We'll be delighted if the ROI is 2. We're going to be disgusted if the ROI is 1. What this means is, if when I'm evaluating these alternatives, if something has an ROI of 2 or better, I'm going to be communicating the fact that that's really great. If it has a value of 1 or less, I'm going to be saying, as far as this measure is concerned, that's not acceptable. And anywhere in between 1 and 2, there's basically a linear curve fit that the closer it is to 2, the more value is given to the to the evaluation. So let's look at another one. Here's another one that's qualitative. High precision of portfolio balance. Is it balanced portfolio or is it not? I mean, is it going to give a good one or not? Don't know. We'll find out in a minute. And then here's another one it's greater than. It's a percentage. We'll be delighted at 75%. We'll be disgusted at 35%. So we can structure criteria this way, and often I'll work with people that have 10 or 15 criteria, and they're pretty easy to structure. You with me so far? Okay. The next thing that happens is, who are the people that are evaluating or adding information to this? And in this case, I've used some abbreviations, and I've got the VHA, I've got the Office of Research and Development, Person 1, Person 2, and I've also put Congress in here. Now, it's not that Congress is going to be doing any evaluating, but we want to put Congress's value structure in here, and I don't know whether this is the Republican or the Democratic side, but we could have multiple Congresses in here. And so what we're going to do with Congress is I'm going to hit this importance button, and I'm going to choose Congress here. And you can see here are the 4 criteria, and here are some sliders that are saying how important, what in my value structure, how important are each of these or in Congresses? And we could do this by proxy, but you can see when I move one of these, all the others move so that this always totals to 1. You might have seen some things up in the bars move too. I'll get to them in a moment. I'll get to why that happened. But so let's say that Congress isn't worried about ROI because they're the Democrats and they don't care about money, but they do want good alignment. They really want a high what did it say? High perception of portfolio balance they thought was really important. That doesn't sound like Congress to me, but we'll leave it there. But the VA, they may think that this is the relative importance of the criteria. Now we have 3 different ways of collecting this information. I'll do, let's go to this one. I'm going to do it in terms of rank. And that just says I'm changing. So this is exactly the same, except now you can't move the sliders. All you can do is say, this one's more important, this one's less important, and just reorder them, and it assigns values to them. This is really handy for working with people that you don't want to train at all. You just give them the criteria and you say, which is most important, which is next most important, or you can even do this with stickies on the wall if you have a group of people. So it's a real handy way of getting that info. So now let's go to, okay, we'll do this. Okay. So the problem's all framed. We know the value structure, the importance that these different constituents, these different members have. Now we're going to go to actually collecting information. And in one of our versions, in the SAS version, you can actually send this out on the web, and people will get a pop-up in a window, in a browser window, and they can move these dots around in the browser window, and when they save, it all comes back to the server. So what this dot's doing, this is called a belief map. It's primarily for qualitative assessments. So let's say we want to look at the disease frequency strategy, and we want to know, does that have good alignment with the VA's goals? Okay? Now, this dot is blue for the disease frequencies. It may be hard to read going through all the systems, but there's a number 2 in here because it's good alignment with the VA goals. And so the VA VHA evaluator is going to put this dot someplace on this belief map, and they're going to put it near the top if they think there is the by disease frequencies has good alignment with VA goals. If they think that is indeed true, they're going to put it up here at the top. If they think it's not the case, they're going to put it at the bottom. If they're very sure of their assessment, they're going to put it over here on the right. You can see it says certainty or knowledge, very high. If they have very little information to base this on, they're going to put it over here on the left. So what that basically means, if they put the dot up here, they're saying, I am an expert. I know a lot about what it means to be aligned with VA goals. I fully understand the disease frequency strategy alternative, and it does a good job of being aligned. If they put the dot, come on dot, move. If they put the dot down here at the bottom, they're saying there is not alignment. So what's it mean if they put the dot over here? Well, it's saying there is no knowledge, but I'm sure it's good. So this is either, we have 2 names for this corner. It's either the flaming optimist corner, or it's the salesman's corner. I know nothing, but it's good. And down here, if they put the dot down here, it's I know nothing, but it's bad. This is the engineer's corner, the pessimist corner. So what happens in reality when you're doing these problems is most of the dots end up in this region or this region down here. People that don't know anything, they actually usually leave their dots right here at the default point where everything starts, which says I know nothing and I'm neutral. And the mathematics that are underneath this totally ignore a point that's right there. You might have also noticed that when I took the point over here and moved it around, this blue bar, which is the overall satisfaction of the blue alternative, that by moving this up and down, I'm having a great effect on that bar. But if I come over here and move it up and down, I'm having no effect. So what happens is we discount evaluations as the knowledge goes down. So let's see. I'm going to hit show all the people. Oh, that's too close. Let's make it more interesting. So here are the two evaluations we've got so far on that. I made them so they disagreed on purpose. You'll see why in a moment. If I go down here, the yellow one, we only have one evaluation. There's not a whole lot of data in here because I just keep using this for a demo. Here's two of them where there's two evaluations, and one of them knows more than the other, but they basically agree that the green one does not have good alignment with the VA goals. So now let's go to a quantitative one, high research ROI, and we'll stick with this evaluator. We'll stick with the green one. It's fine. By the way, whenever there's a bigger dot on here, that's the one that's active at the moment. So we're looking at VA, VHA, criteria 1. And you might notice I can move the dot around here on the map, but there's also a number line here, and you can see that the thumbs down, that's the disgusted value at 1, and the thumbs up, the delighted value at 2. And you can't move those on this number line, but you can move everything else. Okay? And as you move things, the dot on the belief map moves. What these are is what's our most likely ROI value. Okay, let's say it's 1.5. What's the worst it could be? What's the best it could be? Now you can change the scale here so you can read things easier. So how good could it get? And you might notice as I bring these error bounds in, the dot moves over to the right saying, well, I am sure of my assessment. So when a scientist gives me a single number for something, the first thing I push back is, well, give me plus or minus 3 sigma. So at least I have some estimate on what these error bounds are, and I can put in the uncertainty. So here you might see that these two guys basically agree. One of them thinks the information's more uncertain than the other. They were probably presented with a single point, and this person just doesn't trust that single point as much. So let's see. Let's look at. Let's see if there's any. Yeah, it's a similar situation there and there. So if I hit this show all button, here's all the data for the blue alternative. Here's all the data for the yellow alternative. All the data for the purple one. Here's all the assessments we have so far. There could be, if everybody assessed everything, there would be 4 times 4 times 4, so there could be 64 assessments in here, but Congress isn't going to do an assessment, so 4 times 4 times 3 is 48. You can see we have nowhere near 48 dots here. You don't need to. All the rest of them are just stacked up here at the default point. So what happens is the program takes all of this information, takes this value information, combines it and comes up with these satisfaction bars. So if the yellow one was 100% satisfactory, it would be up to 100%, but it isn't. And actually, I want to play a little game here just to make our demo a little bit more interesting. Bear with me a second. Okay. I just put in a point to bring the yellow one down. Now you might notice that there's 4 different levels of yellow one. That's because we got 4 different importances, and let's look at it through different eyes. So now we're looking at it through Congress's weights or importance, and now we're looking at it through ORD2, which says the purple one's leading. The ORD1, by their viewpoint, the yellow one's leading just barely, and by this other one, it's almost a wash. So all of this is too close to call. The thing that's pretty clear right now is the green one, we probably don't want to put any effort into in figuring out what's happening, but we somehow still have to differentiate these 3. So in keeping with the Arthur C. Clarke quotation, we'll hit the What to Do Next button. By the way, I had this button before I found the quote. And it says, hey, you should go back. This is basically a cost-benefit analysis. You should go back and build some consensus on good alignment with VA goals by discrete frequency, by disease frequencies. So let's do that. So we'll go to disease frequencies, good alignment. We'll turn off this. We'll turn off that. And there were two evaluations, and they did not agree very much at all. And this is pretty important. And the reason it's decided this is important is watch what happens if I bring this dot up. You can see the blue one's moved a fair amount. And I'm going to turn on, when I hit team here, it's just superimposing everyone's evaluations. And you can see the blue one has inched up above the yellow and purple by moving up. Likewise, if this guy happened to come down here, come on, let's grab it. The blue one's totally out of the running. So it's important that these guys talk about this one. This is back to Paul Nutt's point. You got to put your effort in the right place. So the effort should be put in here. And what I mean by effort is, do these two evaluators understand what the alternative is by disease frequencies? Are they evaluating the same thing? Do they understand what the alignment with the VA goals mean? Do they understand the goals, and how are they assessing alignment? It may be that they just disagree, but probably with some discussion, they'll begin to agree. So let's say that after some discussion, ORD 1 comes down here, excuse me, and the VA guy says, well, you know, I think he knows more than me, but I think he's about right, so I'll move my dot there. And by the way, Accord records all the major changes so that you can go back and replay things if you want to. So now you can go back to the What to Do Next button, and now it's going to tell you what the next thing to do is in order to slowly tease out which alternative is the one that you should go with. Now there's some other games to be played here. One of the games is, let's say we know that the guy who did the ORD1 evaluations is always optimistic. So what we can do is, you know, he always thinks he knows more than he does. So we're gonna exclude his evaluations, and you can watch his dot right here, and you'll see it disappear to the left because we're just taking him out of the picture, and you can see these satisfactions adjusting. And so without his evaluations in the picture, it looks like the purple one's leading. In fact, we can even make another game. By the way, when we close it, it'll bounce back. We could say that we like the value structure he's using. So here's his value structure. And now we're going to take him out of the, I'll do the same, whoops. Didn't mean to shrink it, I meant to grab it. And now we'll take ORD1 out. So now we've got his value structure, but none of his evaluation. We can take this person out too, and since Congress isn't doing any evaluating, that didn't change anything. So now we've got ORD2's evaluations from ORD1's viewpoint, and we can see that it looks like the yellow one's the best. So you can play all these what-if games to try to tease apart what you want to do in order to bring this to closure. So that's basically the analytical technique. In this organization, what Brad plans on doing is using this in the background, and we may elicit information from our different customers, or maybe us doing the evaluations. Depends on the problem and to be seen. But you know, this means that in order to get, when we're doing our modeling, we're going to be out collecting information not only for the best estimate, but also the uncertainty, and for measures that are qualitative, we're going to have to use some other method. There's a couple people in this organization that have used a method called Delphi, which is a method of going out and asking people questions and taking the results and modifying the questions and going through that cycle. So we'll have to collect the data depending on the issue however we can, and then we present this information to our customers and see what we have. So that concludes the introduction to the accord method, the robust decisions method of doing decision making.